let's see. Okay, cool. So I'm now officially streaming on YouTube. So just be aware that, if you, of course, any of you guys can unmute your mic at any time if you want. This is supposed to be like a very casual like thing, but just note that if you do unmute your mic, you're going to be on YouTube. But again, don't feel free at all to unmute your mic. Should I use day theme? No, I like dark theme too much. Okay. So welcome everyone to the Beginner Cadence Bootcamp. I don't want to spend too much time on this intro because I think you all already understand why you're here. But basically, this is going to be a month-long workshop, month-long bootcamp where we learn cadence from the ground up. This is supposed to be for people that have, some coding experience, a lot of coding experience, no coding experience. It's really for everybody. So because of that, we're going to start with a little bit more abstract, what's a blockchain, that kind of stuff, and then eventually we'll get into the actual coding. We will be coding by the end of this workshop, so we will deploy a smart contract today, but we're going to spend a little bit of time just talking about, the terms. So I'm starting here. I'm going to send a link in the chat here for anyone that wants to follow along, but let's get into it. So this chapter sort of talks about what a blockchain is, what smart contracts are, what dApps are, the terms that you may not understand if you weren't really a developer in this blockchain ecosystem. Um, I think I'm gonna, for the purposes of this workshop, because we're together, of course you can go and read this on your own time. I think it's most important to just point out the biggest stuff that you're gonna need specifically for smart contracts. Okay, so, this first question is, what the heck is a blockchain? The four things that I think are really important to point out are, it's an open, decentralized, public database. Okay, so open in the sense that anyone can interact with it. There are no restrictions to interacting with the blockchain. I can call into it from my home computer. You can call into it from your computer. It's open for everyone to interact with. Um, you know, to read from it and also to write to it if the smart contracts allow. We'll get into that in a bit. It's decentralized, or at least it's supposed to be decentralized, right? In its most pure form. Nobody really owns it. There's no central authority dictating stuff. So unlike Google, where Google has their own, centralized database where they store a lot of data and information, and they have control of it and all that. The point of a blockchain is supposed to be decentralized in nature, right? Um, it's also a database in just the simple sense that you can store information on it. So I use the Flow blockchain all the time to store some basic information, whatever that may be, right? And again, like the example that I always use is NFTs, right? Like at the end of the day, when we're storing NFTs in the blockchain, the blockchain is acting as a database in that sense. We're storing metadata about NFTs. We're storing who owns them, right? All these things are being kept track of by the blockchain, and so in essence, it is a database, and it's public in the sense that anyone can view the data on it. So um, this is, in my opinion, when we talk about smart contracts, this is the most important point, that it's public. That no matter what we do in our smart contracts, we're going to talk about access control, which sort of covers, who can read certain data and all that. But at the end of the day, the blockchain and smart contracts in general are public, so anyone can view the data on the blockchain. So nothing that you put on the blockchain can ever be private or restricted or anything like that. It is always public and readable for everybody. Okay, so just that's an important point, especially when we later down the road get into access control. So then we get into smart contracts, and this is going to be the main point of this entire boot camp is learning Cadence, right? The smart contract language that is used by the Flow blockchain. You may have heard of Solidity, right? That's used on EVM chains like Ethereum. You also might have heard of Move, which is actually quite similar to Cadence. That's used by Aptos and Sui, I think it's called Shui. I don't know exactly what it's called, but you get the point. But let's talk a little bit about what smart contracts are. There's this cool little diagram here where there's like a little note thing with a bunch of like cool little coding hacker numbers on here, and you can see it's like managing money and data, which is what smart contracts do. But let's actually get into some of the properties of smart contracts, just so we can have this in the back of our mind, while we're coding them today. Now, I'm not going to spend too much time on like what exactly they are, because I think it's better to learn by example, and we're going to be coding them in about 10 minutes or so. So let's wait for that. But let's just talk about some of their properties. Okay. So, why do we even use smart contracts in the first place? Well, number one, they're very speedy, they're efficient, and they're extremely accurate, right? They're extremely accurate, and that's I guess that's maybe the most important property of smart contracts. So they are fast, right? It's it's accurate in the sense that the way that you code smart contracts, like it will do that, right? So if you code them correctly, if you have no bugs in your code, it will work very well and it will manage, calls coming into it like transferring money or minting NFTs. And, anyone can see that code, right? Which is where we get into trust and transparency, where, you can look at a piece of smart contract code and know exactly what it's going to do, right? Um, so you can, for example, when you go and mint an NFT, right, it pops up in your wallet and you can see the transaction code that's being run. And you can go inspect the smart contract at a specific address. And you can say to yourself, yep, this code is fine. You can run that code and it's going to behave exactly as you expected, right? So it's very trustful, it's very transparent. And that's, a very important property of them. Some downsides of smart contracts are maybe even more important in that they're extremely hard to get right. Smart contracts are dangerous for developers in the sense that, if you leave even the slightest little bug, it's going to, cause massive problems. And one example of that was the Matrix market hack that happened, or not hack, but bug that happened, I'd say probably like 5 or 6 months ago, where the Matrix market developer team accidentally started exposing users' flow token vaults to the public. And I think like upwards of $500,000 were stolen, or maybe even closer to $1 million were stolen in total across user accounts, right? And that was literally because they messed up one line of code. And you read this thing all the time too in the Ethereum space, or at least you read it much more often, in my opinion, in the Ethereum space, where people leave out like one little line of code. There's something called like reentrancy attacks, and people steal all the money that's in the contract, right? So it is very risky and very dangerous. But if we are good developers, and that's why we're here in this workshop, it'll be okay. Um, so, and also, yeah, you cannot undo something. So, for example, when transfer a flow token to someone else's account, that is final, right? The blockchain keeps track of that state. You can't just undo it. So, we want to make sure that we're taking actions and we're signing transactions that we believe are okay. So let's get into transactions and scripts now, and then we'll get into an example, I promise. So transactions and scripts are in essence, okay, so the simplest way to describe it is that transactions are what change data on the blockchain, and this is the same for any blockchain, right? So transactions change data and scripts read data. Okay, so let's say that there's an NFT on the blockchain, and I'll quiz you all, and if you could please put your answer in chat. When I mint an NFT, right, is that a transaction or a script, and why? And if you can, just type out why in the chat here. If I go and mint an NFT, is that a transaction or is that a script? Yeah, you guys got it right. So it's a transaction because it changes data on the blockchain. So exactly, Dimitri. So not only does it use gas, right, which is what most people associate with a transaction, but the important part is that it changes data, right? So because when you mint an NFT, you're storing data in a user's account, right? So data is being moved around. That is ultimately why it's a transaction, because the blockchain state is changing. Whereas scripts simply read data, right? Where I want to go to the blockchain. I want to say how many NFTs does Dimitri have, and it says 1,000, and boom, that's a script, right? Um, Now, of course, like Dimitri was also mentioning, transactions are paid in the sense that they cost gas. On Flow, gas is extremely low. I think it's like fractions of a penny. Whereas, in the Ethereum space, it could be upwards of like, $500, which is crazy, but you sort of get the point. Um, and scripts are free, right? So it costs nothing to call a script or to read a script. Okay. Now, what else do I want to talk about? Oh yeah, so this other term, this term is pretty important as well. The difference between mainnet and testnet. You'll hear this a lot, and maybe some of you don't know what it means, so I will mention it. The term mainnet and testnet refer to um, like a blockchain that we interact with that is basically like a test network or the real network. Okay, so it may be pretty simple, but essentially, when you think of Flow blockchain, Flow blockchain has a testnet and a mainnet, and the testnet is where developers, test their code, they deploy smart contracts, everything's fake, right? So the Flow token on testnet is fake, but it allows you to sort of like, you know, test your contracts in a simulated scenario, where you can just make sure that there's no bugs, no anything like that. Whereas mainnet is the real deal. So once you deploy your contracts to mainnet, then it costs real money. The flow token is real. Everything is real. If something bad happens, that's really bad, right? So, just sorry, I'm a little bit sick, but this is just a pointer about the difference between mainnet and testnet. And you'll also hear another term called emulator. Emulator is basically the pre-testnet, so it's like the test network. It's really fast, it's really efficient, and it's mainly for testing code on your local computer. Whereas testnet is like a distributed, network. Like anyone can interact with the same testnet, but an emulator is just like for you, right, on your local system. Okay. So dApps, maybe you don't know these, but dApps is basically just a short term for decentralized applications. So dApps is a term used to describe any application, web app, mobile app where smart contracts are used. Pretty simple. All right. Let's head into this one, and this is going to take probably only a couple minutes. This is a little chapter about the history of Flow blockchain. I'm not going to talk about that because I think it's a little boring. But if you're curious about the history of Flow blockchain, you can check it out. Um, I'm going to go to this part right here, which talks specifically about Cadence. So we talked about why smart contracts are what they are, what their properties are. But I'm going to dive into specifically properties about Cadence that differ from languages like Solidity um, today. Okay, so Cadence, and this is actually some basic Cadence code that we will be looking at in a couple minutes here. But these are the five pillars that are on the Flow blockchain documentation. So when you look up Cadence in the Flow docs, this is the five things that they are emphasizing. So I will be talking about them now. So safety and security. This one is pretty straightforward. It's just that in Cadence code, they use a extremely strong typing mechanism that's similar to Swift or TypeScript, where you have to basically um, you know variable declarations are super explicit, right? So you put their type. It's very easy to read Cadence code and know what it's doing. So it is very safe and very secure, which also gets into clarity a little bit. Cadence code is very it's clear to read, right? You can read here. Code should be easy to read. Um, it's again pretty straightforward. Approachability in the sense that if you're familiar with other languages like Swift or even JavaScript a little bit, or Rust, you'll pick up Cadence pretty quickly. Even if you don't move the other smart contract language, you will pick up Cadence very quickly, so it's very approachable. The developer experience is also great. Errors are pretty easy to read. It's pretty easy to understand when things are going wrong. And Cadence will point out to you if something is wrong. So I like to use the term all the time that Solidity, in the Solidity world, it's very easy to foot gun yourself, and that it's really easy to shoot yourself in the foot. But Cadence makes it very difficult for the developer to mess up, and that is why I like teaching Cadence, because I think it's a very good language for people of all experiences. And it also uses something called resource-oriented programming, which is this idea that assets are actual objects that live on chain that we move around and store in people's accounts. This is different from Solidity world, where smart contracts sort of act as like a centralized ledger, where in a contract, it'll basically say, okay, Jacob owns NFT ID 1, and it's literally just a map on chain that says 1 maps to Jacob, 3 maps to BZ, right? Whereas in the Cadence world, and also the Move world, it's very different, right? NFTs are actual objects that we move around on chain and put into people's accounts. So that's sort of what the resource-oriented programming is talking about. Okay, finally, we're done with talking. Let's get into some code, which is way more exciting. Okay, so we are on chapter 2 now, and also just to point out, if you've never coded before, I put a chapter 1.5 in here to help learn coding. But I'm not gonna do that today, but you can always check that out. Okay, so we're gonna open up the Flow Playground. This is play.flow.com, and we're gonna delete everything in this file just because we're gonna start over. Um, yeah, super excited. This Flow Playground is actually pretty new. This is the first bootcamp where we're using the new playground, so double thumbs up. Okay, so there's a lot to cover here. I'm gonna try and do that the best way I can. And please, if you have any questions at all, just ask it in the chat because it's a great way to, just to get immediate help. Okay, so the first thing you're going to notice is that contracts, transactions, and scripts are all different, right? Contracts are in the contracts folder, transactions are in the transactions folder, and scripts are in the scripts folder. This is unique to Cadence, where the contract, transactions, and scripts are actually different files. In the Solidity world, it all comes from the contract, but enough with Solidity. It's a garbage language. Let's focus on Cadence, okay? So the way that it's going to work is, let me actually pull up a little diagram here. I was doing that yesterday. So this is our contract file. Okay, this is what we're going to call a contract. And then we're going to have a transaction and a script over here. So this is going to be a transaction and this is going to be a script. And the way that it's going to work is we're going to define some code in our contract, okay, that says hello or change this in variable. And then transactions call into the contract, and same with scripts. So this is sort of the mental model you should be thinking about, right? That contracts we're going to deploy this to an account, and then transactions and scripts are going to read into it or call into it to do some actions, okay? So this is how you should be thinking about it. So let's go back. So let's actually make our first contract. So the way that you define a contract is you type these exact words. You type pub contract, and then you give it a name. So in this case, let's give it a name of Hello World. All right, let me zoom in a little bit more. So that's exactly how you make a contract. You do pub contract and then the name of the contract, which I'm going to put Hello World because that's the basic example. Now, what we're going to do next is we're going to actually define a little variable. So this variable, let's say we want to make it a greeting. So the way that we define a variable is we type pub let greeting, and we have to give it a type. So this is a interesting conversation about what a type is. So a type is something that describes well, the type of data, right? Is it text, right, which is a string. So let's just type some code here. Let's say we have something like hello, right? Let me put this in comments. Let's say we have something like hello, right? This is a string, okay, because it's text. But if we have something like the number 10, this is actually an integer. Or if we have, true false, this is what we call a boolean, which in Cadence is just bool. What else is there? There's also an address. So when you see an address in Cadence, like I'll get an example address right now. Let's see this address, right? This is what we call an address. So each of these pieces of data has their own type, okay? And in this case, because our greeting is going to be something like hello everybody, we're going to make it a string because it's some sort of text. All right, let me make sure I'm just following along here. Okay, good. Cool. So immediately we're going to get ourselves an error, right? And, we want to put some data in this greeting. But first of all, let's look at this error. It says, uh-oh, on line 9, we are missing an initializer field greeting for in type hello world. So it's telling us we're missing an initializer for our greeting variable. The reason for that is because in smart contracts, you have to give variables a default value. If we were to deploy this contract right now and put it on the blockchain, this greeting variable would be nothingness, and that's bad, right? It can't be nothingness because we're telling it it's a string. So in order to initialize it, you make what's called an init function or an initializer. And in this init function, we have to basically say that this greeting equals some sort of string. And the way we reference this greeting is we say self.greeting equals hello bootcamp people, and we put quotes around it like this. And now we have no errors. So this is a valid contract that lives on the Flow blockchain. And we could deploy this right now, and it would be a perfect contract. Fingers crossed it works. Yeah. Now, some of you may be wondering what the heck this self keyword means. The best way I can describe it is that self just refers to variables defined like above it, like in the scope above it. Um, but you'll get very used to when you have to use self. You'll notice that if we just put greeting here, it doesn't know what greeting is. We have to basically tell it that we're talking about the greeting up here, and the way to do that is just to put self dot. All right. So right now, this contract, right, defines a greeting variable that stores this inside of it. So I'm going to ask a question. Does anyone think, like, if I were to call a transaction that calls into this contract, would I be able to change this greeting? What do people think? Would I be able to change this greeting right now if I were to call a transaction? Yeah, the answer is no, right? And the reason for that is because I didn't define any ability for that to happen. So, again, transactions change data, scripts read data, but at the end of the day, they are bound to using what the contract defines. So if the contract doesn't allow me to change the greeting, the transaction can't do that, right? Think of transactions and scripts as just using the tools that are provided by the contract. That's all they are. They just use the tools that are defined by the contract. So let's go and deploy it. Let's say we want to deploy it to account one. In Cadence world or in the Flow blockchain world, contracts are deployed to accounts. So for example, this address here, this could have contracts inside of it if we wanted to, but in this example, we're just going to deploy it to account one. So let's go ahead and deploy, and it looks like it worked. I think it worked. Oh, yeah, it worked. It says deployed to contract or deployed contract to 0x01 account. Um, awesome. So, quick note, by the way, you'll notice that on the Flow Playground or in emulator formats, the addresses are super short, like 0x01. In the real world, they look like this. It's just that this is like a simulated, thingy. Okay. So boom, we deployed this contract to 0x01. Now let's go to a transaction, or let's actually go to a script and figure out how to read this greeting. Let's go to a script, and this is what a script looks like. Okay, so scripts always look like this. They look like public function main. Then you can put some arguments in here, which we don't need right now. And then you give it a colon and return type. So in this case, because we're going to be reading the greeting variable, what should this return type be? Instead of integer, remember, there's like integer, there's boolean, there's address, there's string. What should we put here? Because we're going to be reading the greeting. Yeah, exactly, Raven. So a string. Okay. So we're going to tell it the type we're returning, and we're going to return hello world, which is the contract dot greeting. But you notice there's a problem. This script has no idea what hello world is, right? We know because we defined it. We know that it's the contract, but this script doesn't know that. And you'll see the error: cannot find variable in this scope hello world not found. The reason, well, actually, I'll ask you guys, why do you think the reason is? What should we maybe do here? And for maybe some of you programmers will know this. Yes, exactly, Ravis. You import it. So the way to tell this program that we need the hello world contract in this scope is to import it. So we import hello world from, and then we deployed it to address 0x01. Okay, and now it knows exactly what we're talking about. And in fact, if we were to type in hello world and just press dot, it actually brings up greeting for us. So it knows everything that we can read here. This is very helpful for beginners, by the way. If you if you press dot and look at the options, we can literally click reading, and it knows exactly what we're talking about. So let's execute this script, and you'll see we get some values. It says the value is hello bootcamp people, and the type is string. So perfect. We have defined a script that is reading the greeting variable. So it just read what this is. Awesomeness. Okay, so let's add a function in here. Let's add a function. Let's delete this for now. Sorry. Let's define a function called public function. Okay, and a function for all you non-programmers out there, a function is something that, executes some sort of action. So unlike a variable, which is basically just something that holds data, right? This is what we call a variable. A function is something that will like do some code. It will take some action. Okay, so let's call this function change greeting, and this is how you define a function. It's public fun, the name of the function, and then inside of here, actually, first let's open up our function. So the way we open up a function is with curly brackets. So we're gonna put the code that we want to, the action we want to do inside these brackets. And one more thing we can do is we can pass in a new greeting. So the ultimate goal is to change this greeting to some value that we pass in. So let's do that. We can say new greeting, which is also going to have a type of string. We're going to pass that into this function, and then we're going to say self.greeting equals the new greeting, okay? And we're going to get an error here. It says cannot assign to constant member greeting. The reason for that, it's actually a very small thing, but it's important, is this let keyword. So let, if you've coded in other programming languages before, let is the same thing as const or constant. It basically means that greeting cannot be changed. So it's not liking this right now because we're changing greeting to some other value, but we put let here. The way to change that is just to put var. So if you put var, that means you can change that variable, okay? Awesome. So we've now defined a function that, basically receives a new greeting as a parameter, we call it a parameter, and we're setting self.greeting equal to the parameter that we passed in. Okay, so let's go ahead and deploy this contract again to account one. All right, we deployed it. Boom. And now let's go back to our script. Now let's execute again. And we get the same thing, right? It's equal to hello bootcamp people, because when we deployed this contract, it set greeting to this initial value. But now let's try and call a transaction to change it. So let's go to a transaction. And now, welcome to the world of transactions. So it definitely looks a bit different. So what is different about it? Well, it always looks something like this. Let's actually delete this and open this up. And I like to call this signer instead. But this is like the basic format of a transaction. You put the transaction keyword, you put some, your parameters in here. We're not going to have any at the moment. And then there's two phases. There's prepare and there's execute. I'm actually going to completely ignore prepare for now. And so if you have any questions about it, don't worry, it's coming. But just ignore this for now. We're going to simply focus on execute. So execute is where we put all of our code that we want to, perform actions. Okay, so inside execute, we're going to say hello world dot. Uh, oh, I wonder why it's not popping up. I usually it's helpful for people if it pops right out. Let's try. Let's try and refresh the page maybe. Let's see if it pops up now. Oh, there we go. So if we press dot here, you'll see the change greeting actually pops up. So we can press change greeting, and we're going to pass in a new greeting here. So let's say, we want to pass in goodbye bootcamp people, right? And put an exclamation mark. We can go ahead and sign this from somebody. So, who do we want to be? Let's say we want to be, I don't know, person four. Okay, so let's say this is me, and I'm gonna send this transaction, right? So I'm signing this transaction, or I'm quote unquote paying for this transaction, in with gas. But again, gas is super small. Let's send it, and it's sent. Okay, we got no errors. So if we go back to our script now and we try and execute again, up it says goodbye bootcamp people. So it successfully called change greeting. It passed in goodbye bootcamp people as our new greeting. And then in our contract, it received that right here and it set greeting equal to goodbye bootcamp people. How are we doing? Are people doing good? Are we lost? If you're doing good, thumbs this message up. If you're doing bad, thumbs this message down, and there's no shame in that. I will be very happy to keep going. But I hope okay, good. Looks like people are doing good. So Dimitri says, so right now anyone can change it, and you are absolutely correct, Dimitri. Right now, because this contract is defined in a way where this is available for everybody, and we'll get into access control later, but the short answer is that because we put pub here, so public means it's public, anyone can call this, this function. So if I were to deploy this on testnet right now, all of you could call this change greeting function and change it as much as you want. Yeah. Great question, by the way. Great question. This will change when we get to stuff like access contract and whatnot, but this is a more advanced concept, so we'll leave it public for now. Okay. Cool. What else? Okay, I got so deep into the lesson that I forgot where we even were. Um, okay, I think that so we just covered chapter 2, lesson 1. Let's try the next one. Um, oh yeah, so I was hysterically laughing at myself a couple boot camps ago because I made this diagram and it looks so stupid. But if you want like a simple diagram of transactions and scripts, you can read this too. So there's a person that wants to modify the blockchain, call a transaction, which calls into the contract, or they call a script that views it, and you get the point. But there's a helpful diagram there. Um, this is also a very helpful diagram to help figure out the difference between a transaction and a script. A transaction looks like this, where we have prepare and execute, and a script looks like this, where we have public function main and a return type, okay? So this is a little diagram I made too. What else do we want? I think I actually covered this already. Um, okay, looks like I covered this already too, so boom. Um, The only other thing I want to mention for today is a little bit about prepare. Again, we're going to get into this a lot more later, but the prepare statement is where we can access information about who signed the transaction, okay? So in this case, what we can do just to make things fun is we can do something called log. Now, logging is just a something that allows us to print something to the terminal here. Please note that in the real world, in testnet and mainnet, logging is completely useless because it doesn't do anything. It only is helpful for like debugging and emulator purposes. But let's put inside here, like if I log hey, if I just put hey, then when I send this, you'll see it actually just prints hey to the console. So what we can do is we can print signer.address, okay? Signer.address. And what this will do is this will take who signed the transaction and print their address. So this is just to show you what signing really is. If I were to sign in with account 2 here and send it, it prints, oh, well, this is sort of like it's like a weird feature of the playground, and maybe Dimitri, this is some helpful feedback, but the playground right now always prints things in like hexadecimal, or I don't know what the term is. Maybe Austin would know better, but it prints things in a different format. Like it doesn't print them as OX02. It like converts it to OX0006, which is maybe confusing for people. Um, but anyways, the point is that it should be OX02 here. And if I were to do it with account 4, it prints, it should print OX04. It's just converting it. I'm sure that'll be fixed. But yeah, so that's what signer is. And later down the road, when we talk about account storage and all that complicated stuff, you'll notice that the auth account is actually the most dangerous type in Cadence, and it allows you to completely manipulate an account. But we're gonna get into that later. Okay. Cool. One more thing I want to note is that what if instead of, hard coding this value, and hard coding is basically where you like, specifically like how do you define hard coding? It's like where you like put a specific value in code that isn't like dynamic. So what we can do instead is we can pass in a transaction argument called new greeting, or let's just call it user input, just to make it more clear, user input, and then we're going to make it a string, and we can pass user input into here. And this is actually a lot nicer because we can literally type into this box now. You'll see we put user input. It creates a field for user input up here that we can type into here and say, let's say this workshop is almost over. Okay. And now I can sign it. Let's just say from account 5. I'm going to send it. What it did was it took this string, it passed it into here, right? Which then got passed into here, which then gets received here, and we set our greeting equal to that variable. So if we were to go ahead and run a script now, you'll notice it says the workshop is almost over. And we can do that one more time. Let's just say, Austin is a cool person. If we send it and we go back to our script, now it says Austin is a cool person. Does that make sense to everybody? That we can pass in what's called transaction arguments and then use that in our transaction. So a transaction input can be anything. Yes, it can be anything, but so let's actually try something out. So let's say, okay, let's actually do some modifications where instead of a greeting, we have a number that's an integer, and we have to change some types around. So let's say this is a number. Let's just say a new number, and we're gonna say number equals 10. Okay. So I just basically changed everything to be from a greeting string to a number integer. Let's deploy this. Let's go back to our transaction. And we obviously need our user input to be an integer. And we need our this to be dot change. We have to refresh the page. Hold on. Dot change. Wait. Oh, change number. All right. Deploy that. Go to our transaction. Change number. Boom. New number, which is just going to be user input. The reason I did all that is just to show you that because we're accepting an integer now, we can't type, let's just say like Dimitri, right? It says should be valid integer number. So we have to type in numbers now because it's expecting an integer. So we have to type, 10, or let's just type in like 100. And when we send this, if we go back to our script, hello world.number, let's see. Oh, we're getting an error. Mismatched types, expected string, got int. Anyone know how we can fix this error? What's the problem right now with our program? Yep, Cheetah, you're definitely right. But more specifically, what exactly do you have to change here? Yeah, line 3, right? So I'm assuming you're talking about this one, right? So we have to change the return type because it's supposed to return an integer now. So now the error is gone. We can execute and we get 100. So yeah. And besides that, there's some other like data that we just haven't talked about yet, like arrays, for example. Arrays are like lists of integers. So this is like a list of integers. I don't think you can put that on the playground though. I think playground only supports very basic types like integer, address, string, boolean. I don't think it supports like lists and dictionaries. It'd be awesome if it did, but I just don't think it does. Yeah, if it, I would say Dimitri for the team, if there is any feedback, definitely the two that would be most helpful are arrays and also dictionaries, which is like a mapping. So like you map a string to an integer. This would also be so nice, but we'll get into that later. Great question, Eric. So Boolean is a different type of data. So we were talking about this earlier, where like hello is a string, 10 is an integer, where true is a Boolean. So Boolean can be two things. It can be true or it can be false. It's literally just like a toggle. So this can be true or false. That's a Boolean. And then like OXO1 is an address. Um, Arrays are things like lists of integers. So like 0, 1, 2, 100, 84, I don't know, like uh, 3. This is like a list of integers, but we'll talk about this in the next lesson. Yeah, Raven. All right, cool. That's it for today's workshop. I hope that was helpful. We deployed our first contract. We talked about what transactions and scripts are. We talked about what variables are. We talked about what functions are. We talked about the difference between var and let, right? So var and let is also pretty important. We talked about initializers. Oh, great question, Strix. So to submit quests, put them in any note stock of your choosing. That can be you can upload it to GitHub. You can put it in a Google Doc. You can put it wherever you want. Most people do GitHub. I'll show you an example of that where in this quest submit channel, you'll see Ricardo, who is one of our previous instructors. He actually uploads all of his content to GitHub under different folders. Like you can see the folders here. And he puts like an answers file where he just puts all of his answers. It's totally up to you though. You can use any note stock you want. And then once you complete a chapter, so my only ask is that you don't submit feedback for every lesson because it'll just be too much. When you finish a chapter, like a whole chapter two, then you can send the link to that in this quest submit channel, and it'll create a thread, and I will answer in that thread. Thanks, PC. Bye bye. Oh, nice, Dimitri. So use this link if you have any issues. All right, cool. Thanks, everybody. And I will see you on Friday at the same time. So, Friday at the same time. If you're curious, for Friday, we will be talking about. Um, we will be talking about. Where's the boot camp? Chapter 2, Lesson 3, and Chapter 2, Lesson 4. So, we're going to basically finish off Chapter 2 in the next one. All right? Cool. Bye, everybody. Enjoy your Wednesday. Of course, Eric.
Bye, guys. Bye, everyone. Thank you.
Bye bye. Thanks, Dimitri.
Yeah.